Welcome. So I'm going over, this is coming from section 2.8. This is graphing linear inequalities. And this is necessary for when we start talking about functions because we talk about something called domain and range, and we write our domain and range in the term of interval notation, which is basically an inequality, and graphing it makes it really easy to write the correct notation. So just a review of what our inequality symbols are. We've got the less than or equal to, the greater than, and the greater than or equal to. And we always read these going left to right. So everything we do with inequalities goes left to right. So you always want to have your x on the left side. So if you have 2, you're less than symbol than 5. That means 2 is less than 5. So always left to right. So those are the inequality symbols. So what is a linear inequality? Well, we know linear equations. Those are equations where you have an equal sign, hence it's an equation, and it's got no exponents on the variables. So a linear inequality has the inequality symbol instead of the equal sign, and there's no exponents on the variables. So the only difference is the symbol used in between the left and the right side. And then we also have compound inequalities where you have 2 inequality symbols instead of 1 to basically indicate that you are between 2 numbers versus being less than or greater than. So this table shows all the possible combinations of inequalities that you can see when you are solving or graphing, basically. These would be your final answer, how you would see your final answer when you solve. So graphing linear inequalities. So unlike equations where you solve and there's one number that makes it true, there are many numbers that make an inequality true, because if you have an inequality saying you're greater than 5, well, there's lots of numbers that are greater than 5. There are infinite solutions, so we can't write a single number. And it's more helpful to take a number line and put on the number line, shade the area where the solutions are so you get a visual of where your answers are. So you basically highlight or whatever the section that contains your answers or your solutions that work. And then you have endpoints, and those are either using brackets or parentheses to indicate like when to stop. If that endpoint is part of your solution, use a bracket. Some places use a closed circle, but we're going to use brackets. And then if it's not included, you use parentheses or an open circle. But we use parentheses, and we use brackets and parentheses because those are useful when we do interval notation, which I mentioned earlier. So here are all those 8 possible inequalities that I had earlier that we could get when we're solving or graphing. And so I'm going to show how you graph these on a number line, so you can kind of see visually what they look like, and then you can use this as a helpful chart when you're graphing. So the first one, we have x is less than a. So a is just some number, and I've got a labeled on the number line. So less than a means that our answers are smaller than a, and smaller numbers are to the left. So I'm basically highlighting all of the numbers to the left of a. Now we have to indicate what happens at a. So a is not included because it's less than a. It's not less than or equal to a. So a is not included. And if it's not included, we use a parenthesis and we face where we shaded. So I've got a parenthesis here, and it faces the direction of the shading. I like to think of parentheses as being the ones that are not including it because it's kind of curving away from the number if you think about it. So it's not touching a, it's kind of curved away from a. So that's how we shade. And then sometimes people will put like arrows here. So the next one we have is x is less than or equal to a. So this is near identical, and instead of using a highlighter, you could just kind of highlight over the line here. It's near identical, but the difference is when a is included, because you can also be equal to a, it's a bracket. And so I think of that, oh, it's straight, it touches a, so a is included. That's how I visualize this. I'm going to change to a different color because that is not showing up very, very good here. Let's just make that purple. So I'm going to change the other one. There we go. The next one, x is greater than a. So these are numbers that are bigger than a. So these are all going to be to the right of a because that's where the bigger numbers are. So you're highlighting your number line. And then we're not including a, so it's a parenthesis. So you may notice that the less than and the greater than symbols, those use parentheses. So less than usually actually ends up with a parenthesis going that way. Greater than has a parenthesis going the other direction. Sort of the opposite direction of what the inequality symbols look like. Next one, we have x is greater than or equal to a. So greater than includes everything to the right, and equal to means that we can include a, so that's a bracket. So the less than or equal to or greater than or equal to symbols are brackets, greater than and less than. So you can indicate them, match up the correct symbol. So those are brackets that are used. It's very different on your keyboard. There's a difference between parentheses and brackets. And when you're doing stuff by hand, you want to be very clear the difference between your parentheses and brackets because they can look similar if you're messy. So you want to make sure that it's very obvious which one you're doing. Now the next one, we have a is less than x and x is less than b. This is telling us that x is between a or b. So our solution is in between a and b. So I'm going to highlight the numbers between a and b. And you always have your smallest number on the left and the largest number on the right. So it's always in order left to right on the number line. And they both have less than symbols. But in this case, the parentheses that you use for a less than, they always face towards the shading. So this is one case where the less than is actually using the other parenthesis because they're facing, you always face the shading. Next one, we have a is less than x and less than or equal to b. So we're still, our answer for x is still in between a and b. Now we've got a is less than x, or you can read that if you look at the other direction. If you read it from right to left, x is greater than a. So we've got our facing the shading. And you can actually, that's the symbol that I associate with the greater than if you read it as x greater than a. And then x is less than or equal to b, and less than or equal to is a bracket. And again, when you face where you're shading. So we've got a combination of symbols here. Next one, we have a is less than or equal to x and less than or equal to b. So again, our solution is in between a and b. And then they're both equal to, so they're both going to be using brackets. And they're going to be facing left and facing right. And then our last one, we have a is less than or equal to x, and x is less than b. So we're between a and b. And then we've got our first symbol on the left is at the less than or equal to, so that's a bracket. And then on the right, it's a less than, which is a parenthesis. And just for notation, to go back to what I said earlier, if you have something that says a is less than x, when we read it the other way, you do a mirror image, and that is the same as x is greater than a. So you just completely do a mirror image. The inequality changes direction when you flip which side it is, when you read it from right to left. And so then you can see that we're actually using our greater than symbol for that left side, because if you write it in the side that we normally use it, it's the greater than, and that's the parenthesis facing to the right. So this is how all these look. So what the numbers are will be different, but these are all the basic shapes that you will see when graphing. So all you really need to do is look at this chart and say, okay, which inequality do I have? Figure out what your numbers are, and then draw your picture. So as long as you have this chart handy, it's pretty easy. So I'm putting into this some other things that are more than graphing, but actually are very helpful for graphing, or we use graphing to write. So there's a specific type of way that we write our solution called set builder notation. And it's called set builder notation because it tells you how to build the set of solutions. And it's basically in the form where you've got a curly brace. So these curly things are called braces. So again, you need to be very careful with your notation that it doesn't look like a parenthesis or a bracket. This symbol is above the brackets on the keyboard, so you'd have to hit Shift to get to them. Let me draw this one a little better. I can draw these really nicely. You can get practice with it. You know, if you're doing it on paper, you can rotate and kind of draw a seagull if you ever did that when you were a kid. So it's surrounded in between there, and that's how we use to indicate that we have a set, is we use these little symbols. And then we've got our variable on the left that just tells us what is our variable that we're solving for. So we have x. And then you have this vertical bar. So it's just a straight bar. It's a vertical bar. I usually read it as the word where. You can also read it as such that, which is what the book indicates. They read it as such that. That vertical bar is above the enter key on the keyboard. You have to hit Shift to get it, but it's same key as the backslash if you're wondering where that is on the keyboard. So it's just a straight line, basically only one of the absolute value symbols. And then you put in your inequality. So this picture here, you would read your set builder notation. You hit your brace, which tells you have a set. So it's the set of, and then your next thing is the variable. So the set of all x's, which is just, you know, all the variable numbers we can plug in for x. You hit your vertical line, such that, or where, and then you have your inequality. So x is greater than or equal to 2. So that's how you read set builder notation. Set builder notation is super easy because once you have your inequality, you just have to plug it into the location that I have labeled inequality and you're done. So it's super easy to work with. Now, the other type of notation that we use is interval notation, and this is the one that's used when we're doing with domain and range a lot of the time, and this is the most commonly used in levels of math starting college algebra and higher. So this is the one that you really want to learn. And interval notation looks like an ordered pair. So you have to be careful. You have to know by context whether what you're looking at is an ordered pair or interval notation. And you create your interval notation directly by looking at your graph. So it's helpful to graph your inequality first and then do your interval notation, because then you're just basically reading the graph. So that's why I'm throwing it in with this thing about graphing linear inequalities. So basically, when the directions for doing this, or the tips for interval notation, is your endpoints in interval notation are always written from left to right. Everything we do is left to right here. So the smaller number always goes first. Then there's a comma. That's why it looks like an ordered pair. And then there's a larger number. So it always has to be smallest, comma, largest. And if you're reading it off of the number line, you read it off the number line left to right. And then you use parentheses or brackets based off of whether those endpoints are included or not included, just like we did with graphing. The graphing, we use parentheses or brackets. And you do have to indicate infinity or negative infinity, which basically means it goes on forever. It doesn't stop. And parentheses are always used with those because we can't actually, those are not reachable numbers. So we cannot actually include a specific number there. They can't be reached, they can't be touched. So that's why I use parentheses. So I've got the same chart, the same inequalities that we saw before. I've added in a column what it looks like in set builder notation. So you can see the set builder is just literally plugging in the inequality. I've got the graph here, so we're going to fill in the graph, and then we're going to read the graph to turn it into interval notation. And what I did with my graph is I added in the locations of negative infinity and positive infinity to help you read the graph. So I recommend when you're doing your graphing and you draw your number lines, label those because it will help you immensely. So first one is x is less than a. So less than a, so we're to the left by the smaller numbers. And less than uses a parenthesis facing the left, basically. So if we read this in interval notation, you start at the left. On the very left point that we have graphed is at negative infinity. So I'm going to put negative infinity first. And then I stopped graphing at the letter A. At negative infinity, we always use parentheses, and it's going to face towards the shading. So we shaded to the right of negative infinity, so your parenthesis faces to the right. And then we have a parenthesis at A facing to the left, so you use that same parenthesis. So you can see that you're almost basically taking your graph and turning it into, you're just plugging in those endpoints and writing it. It looks like an ordered pair, but you know it's not an ordered pair because you can't have ordered pairs involving infinity. So, and yet you know by context you're dealing with, you're not graphing like 2D, x and y, you're only having an inequality. So the next one we have x is less than or equal to a. So less than is to the left of a. And then the equal to part means we're using a bracket facing the shading. So in interval notation, our two endpoints, our left endpoint is still at negative infinity, and then we stopped shading at a. Infinity always has a parenthesis, and the shading's to the right, so the parenthesis faces to the right. And then at A, we have a bracket, so I'm going to just use a bracket there. So you can see the difference in interval notation between less than and less than or equal to is one symbol. So details matter, and making sure your symbols look like the symbols you mean are really important, because if your parenthesis or your bracket, if they look too similar, they're going to look like the same answer, and they're not the same. So you have to be very careful about that. So be very careful that your bracket is not a parenthesis. So next one, we have x is greater than a. So that means I'm going to the right where it's bigger. And greater means I'm not including my parenthesis, or not including a, so it is a parenthesis. It faces to the right where we're shading. So reading this from left to right, the first part we start shading is at a, and then we end shading at infinity. At a, we have a parenthesis facing to the right, and then at infinity, we always have a parenthesis, and it faces the shading, which is to the left. So this, again, looks like an ordered pair, but it's not because it's got infinity in there. So the next one we have x is greater than or equal to a. So greater than, the bigger numbers are to the right. And then equal to a means we have a bracket. So when I write my interval notation, the only difference between this and the one above it is going to be there's a bracket at a. So again, very important to notice the difference between the less than and the less than or equal to, because it is a very subtle difference in your answers. Now, our compound inequalities here, the ones where we're in between. So we have a as less than x, which is less than b. So we're in between a and b, and they're both less thans. So there's parentheses facing the shading. And you read it left to right, so our left endpoint is A, the right one is B, and they both have parentheses. So this looks like an ordered pair, so you need to know the difference based off of context that you're dealing with inequalities. You're not dealing things with x and y. The one underneath it, the only difference is that between A and B, A is still a parenthesis because it's still less than, but we have less than or equal to at B, which turns into a bracket. So your interval notation looks nearly identical, but there's a bracket at B now. Then we have A is less than or equal to X, which is less than or equal to B. So we're in between A and B, and they both have less than or equal to symbols, so they're both brackets. So now it looks like an ordered pair, but with brackets. That was definitely, I don't know why that did not look straight. There we go. And then the last one, we have A is less than or equal to X, which is less than B. So we're in between A and B. Less than or equal to X is a bracket. Less than B is a parenthesis. So we have a bracket at A and then a parenthesis at B. So you can see there are very subtle differences between each of these in the interval notation. But if you look at the graph is basically giving you the interval notation, and you just have to fill in the numbers. And these are all the possible combinations that you're going to have. So if you have this written down, then when you're solving or you're giving things to graph, all you need to do is reference this, and it will tell you where to plug in your numbers. Because basically, you're going to be plugging in whatever A is, and that's going to be wherever it's going to be replaced in your interval notation. But the negative infinity will be the same there if it's in the same form. So all you really need to do is figure out what number is A, what number is B, and then you plug it in. So I've got many examples here. So we're given the inequality X is greater than or equal to 7.2. So the way that we graph this is I'm just going to graph a number line. And I always label negative infinity and positive infinity. I like to put 0 on my number line just so I have a reference point. And then I'm going to label 7.2. It doesn't have to be exact. We just need to know whether 7.2 is to the left or right of 0, just for reference, but it really doesn't matter. You don't even really need to put 0 there. I just like to do that just to show which part's negative, which part's positive. So once you put in your number line where X is greater than, so greater than is to the right, so I'm going to shade to the right, or equal to, which is a bracket, so it's facing the shading. And so we've got a bracket at 7.2, and then we're shading to the right. So now we give this solution in interval notation. So I'm going to just write it directly below. We start shading at 7.2, and we have a bracket there, comma, and then we stop shading at an infinity, and an infinity always has a parenthesis. So if you want to get really creative, you can think of this arrow as a parenthesis, and then you can really see that it's just giving you your interval notation in your picture. Here we have X is less than 1. So again, drawing my number line, you're going to get really good at putting your infinities. Actually, less than -1, I think I said 1. So -1 is to the left of 0. So less than is to the left. So we're less than -1, so we're to the left of -1. Less than does not include the point, so that's a parenthesis. And then instead of like coloring in my arrow, I sort of turned my arrow into a parenthesis so that you can see that the parentheses are always at the infinity parts. So in interval notation on the left, I have a parenthesis at -infinity, comma, and then I stop shading at -1, and that has a parenthesis because it's less than, so it does not include -1. Here we have given that we have -12 is greater than or equal to t. So we always read these left to right, so we're going to translate this into something that we read left to right with the variable on the left. And when you do that, it's a mirror image. So this is the same as saying that t is less than or equal to -12. And that's how we're going to read it. So I'm going to put in my number line. With negative infinity, infinity, I've got 0. I'm putting -12 on here. And it doesn't matter that it's not x. What matters is your picture. So t is less than -12, so that's going to the left. And it's less than or equal to, so it can include 12, which means that we have a bracket. So in interval notation, the left part that I have shaded is at negative infinity, which is a parenthesis. Then I stopped shading at -12 with a bracket. X is greater than 5. So I'm going to draw my number line. Negative infinity, positive infinity, 0, 5. So greater than is to the right. I'm hitting parentheses at infinity. And we're not including 5 because it's greater than. So 5 is not included, so that's parentheses. So in interval notation, from left to right, we have a parenthesis at 5. And then we went all the way to infinity, which has another parenthesis. Here's a compound inequality. We've got -3 is less than or equal to m, which is less than or equal to 8/9. So with fractions, I find it easy to, or better to convert it to a decimal so that I know kind of where to put it on my graph. So 8/9 is equal to 0.88 repeating. So that just gives me a visual of where I want to put on my graph. It doesn't really matter because I'm not being exact here, I'm just sketching. But like if you're putting this on a computer, you need to know where it's located. So like that's almost at 1. So that's like 8/9 is a little bit before 1. So if you're graphing this on something where you have to be more exact, you need to actually know what decimal approximation it is so you put in the correct location. So whenever we have a compound inequality, we're in between these two numbers. So we're in between 3 and 8/9. And on the left at -3, we have a less than or equal to, so that's a bracket facing the shading. And then at 8/9, we have a less than or equal to, so that's a bracket facing the shading. So this translates to a bracket at -3. And then we shade until we hit 8/9, and then we have another bracket. So that's what our interval notation looks like. -4 is less than y, which is less than negative, or less than 1. Man, I'm just not saying my numbers correctly today. I may not have even caught all of these. So if what I say doesn't match with what it says on the paper, that's on me, because apparently I can't talk today. So I'm putting my endpoints -4 and 1, and I'm also putting 0 just for context so we know where things are. We're in between -4 and 1, so I'm going to make sure that I shade that part. And we have -4 is less than y. The less than is a parenthesis facing the shading. And then we've got y is less than 1, so that's a parenthesis facing the shading. So we have two parentheses here. And in interval notation, when we read it left to right, we've got a parenthesis at -4. Then we stop shading at 1 with another parenthesis. One is less than p, which is less than or equal to 8. So, oops, I think I accidentally hit the black color instead of the white. They're right next to each other. So I'm putting my negative infinity, positive infinity, putting 0, 1, 8. So compounded inequality, our variable is in between these numbers, so our answer is in between these numbers. So we're shading in between. At 1, we have 1 is less than p, so less than is parenthesis facing the shading. And then we have p is less than or equal to 8, and less than or equal to, the equal to is always a bracket. So I have a bracket at 8. So we put this in interval notation. At 1, the left, we have a parenthesis, and then we stop shading at 8, and we have a bracket. And now this is my last one. We've basically gone through all the possible combinations that you can see these things. So graphing my number line, negative infinity to positive infinity. We've got negative 3 and 3 as our endpoints. So we have t in between negative 3 and 3. So our solution is in between negative 3 and 3. At negative 3, we have less than or equal to t. So it's got that line under the symbol, which is straight. So that might help you remember to use the bracket, which is straight. Then at 3, we have less than, which is parenthesis. I'm not being very good at covering. I'm trying to like color over it to make it darker, and I just keep missing it apparently. So in interval notation, reading left to right, we have a bracket at negative 3, and then we hit 3, and we have a parenthesis. So that's graphing linear inequalities, and that's how you write your answers in interval notation. I would definitely use my little sheet here as a guide, because all you need to do is plug in the numbers, and you can then compare all of the answers I did to this, and you can see that it matches. And then the next thing you need to do is learn how to solve linear inequalities, which basically involves the same rules for solving equations. There's just one additional rule that you have to worry about, which happens when you're multiplying or dividing by a negative. So I have a video on that, and I recommend that you watch that next. So hopefully this was helpful, and I will see you in the discussions.